My voice is better today. How about that? A couple things. First of all, today we're going to learn about electricity. And electricity is one of my favorite topics. Here, let me get rid of some of that glare down there. So electricity is one of my favorite topics because a lot of people think electricity is like magic. It's like you can't understand it. It's just you got to memorize it, and nothing could be further from the truth. Electricity is just like anything else. It makes sense. It's simple if you know the vocabulary. So that's where we're going to start. So when somebody tells you that we know what goes in and we know what comes out, but everything else is kind of magic in between, not true. We started you off with static electricity, and we talked about charge, positive, negative, and it always had to do with electrons, didn't it? Positive charge was too few electrons, and negative charge is too many electrons. So we talked about induction, where if you come in with a bunch of negatives, it takes negatives from something else and pushes them to the other side, and that object that's been inductively charged becomes polarized. Well, electric current starts from that premise. So before we get started on how we turn static electricity into moving electricity, we have to understand these words that are on this board right here. So we're going to start with Coulomb, and what does a Coulomb mean? This was my big problem in college. My professor always said a Coulomb's just a unit of charge. Don't worry about it. That's where the magic happens. You don't understand what a Coulomb actually is, you're never going to understand electricity, because it's always going to come back to that, oh, that's just coulombs of charge. You know, it's a unit of charge. That's just a really poor definition. Coulomb is actually a packet of electrons. If you looked up Coulomb in the dictionary, it would tell you 6.25 times 10 to the 18th electrons. That's bigger than your stimulus package that was just put out there by a long ways, by lots of zeros. So a Coulomb is a whole bunch of electrons. Now, to understand electricity, I want you to kind of picture a Coulomb as a packet of electrons. And you're going to hear me say that. You're never going to hear anybody else say that, I don't think. But I'm going to want you to memorize it as a packet of electrons, and those electrons travel together. Once you have that packet of electrons, you could call it an electron guy or a Coulomb guy or whatever. Picture a little Michelin man made out of electrons. Then the rest of the vocab makes perfect sense. A voltage is the amount of potential energy, sometimes they call it electrical potential, of that Coulomb guy. How much energy does he have? The actual base unit to a voltage is a joule per Coulomb. Energy of a Coulomb guy. How much energy does he have? In other words, remember, energy, potential is work in, kinetic is work out. So that potential energy, that amount of work that a Coulomb guy can do, that packet of electrons can do, that's voltage. Another one is current, or amperage. Amperage, current, kind of interchangeable words. In the idea of current, we're talking about the speed of that Coulomb packet or that Coulomb guy. How fast is he? So voltage, how much work can I do? And amperage, how fast can I do it? So just like anything else that we've studied, power is how much energy I can do, or how much work I can do, and how fast can I get it done. So if I put voltage and current together, or amperage, I get power. Now, some of you probably should be saying, why is current an I right there? Why isn't current a A or a C or something like that? Well, that's because it stands for induction. Remember, when we induced current in static electricity, we moved it from point A to point B, and then we polarized it. We have a positive side and a negative side. In electric current, that's going to be what establishes our electric field, which establishes our electrical potential and how much can we do. So the bigger, the stronger the field, the higher the voltage. And what we've basically done is separate the electrons from the protons, and now they want to go back home. They want to get back home to that proton they came from. And to do that, we're going to make them do some work. So it's going to take us work to pull them apart, and then there's going to be work coming back out. The last thing I want you to know is this resistance term. The resistance is exactly what it sounds like. It resists the electrons from going where they want to go, and it resists them from being put where we make them go. We call them this little horseshoe an ohm. So if you've ever heard of a 4 ohm resistor or a 2 ohm resistor or a 1 ohm, the smaller the number, the bigger the speaker. If it's a speaker, sorry, or a resistor, a 1 ohm, has a lot of current running through it because there's very little resistance. The bigger the resistance, the smaller the current. And then that also plays into the formulas that we're going to talk about in the next video. So 5 huge terms to create electrical current and to understand it well. Let's pretend you don't know it. I'm not going to repeat it. You're just going to play the video over and over again until you get it down. We'll talk to you next about the formulas that you're going to need.